Welcome to section 1.6, Reflections, Absolute Values, and Other Transformations. Let's start with reflections. Okay, so here we want to take this image, f of x, x squared minus 8x plus 17, restricted to the values of x between 2 and 5. And we're going to take this graph and figure out how to reflect it across the x-axis and the y-axis. So let's start with the x-axis, since that's what most people seem to understand intuitively. First, let's get this equation into our calculator. I've sort of jumped ahead there and put it in. So x squared minus 8x plus 17. Notice how the whole function is in parentheses before we divide by the Boolean restriction. That's very important. And then our Boolean restriction is split into two conditions, 2 less than or equal to x and x less than or equal to 5. So once we've got that in there, let's go in and take a zoom standard 6. There. And there we see our partial parabola. Right? If we went back and checked our window, we can see that zoom standard gives us a 10 by 10 window. So now we have our graph. And to reflect across the x-axis, we want to think about what's going to happen to the values of our graph. So for the x value at 3, we want to replace the y value with its negative. And the x value at 4, we also want to replace with its negative to create this reflection across the axis. Every y value in the reflection will be the negative of the original y value for each value of x. So the way we would work that out, we would take our original equation, y equals f of x, and we would multiply every value of f of x by -1, every y value. So our transformed equation, I'll use g to represent the reflected translation, would be -1 times every value in the original equation. And if we were going to use this specific equation, then what we'd want to do would make it look like this. G of x would be negative of the entire expression. All right? Now let's think about what should happen to reflect this image across the y-axis. In that case, we'd want the same y values, but instead of getting that y value from 3, we'd want to get that y value from -3. So, and the y value for 4 from -4. So the x's in my equation, I'd want to convert from their original value to the negative of their value to produce the same y value. And I'm going to do that by replacing every x in my original equation with its negative. So if my original equation is y equals f of x, I want to replace each x value with its negative. So I'll let h be the reflection across the y-axis, and I obtain it by replacing every x with its negative. For our specific example, the equation would look like this. Notice how every x in the equation has been replaced by -x. All right. The last thing we're asked to do is to plot the image and the two reflections on the same screen. So let's go back to our calculator. We've already got the original image. Let's think about how easy it would be to find these two reflections. Now first, to reflect again across the x-axis, we want to take our original function and multiply it by -1. So I'm going to hit the negative sign not the minus sign, but the negative sign. And then I'm going to take the negative of what's in y1. Function y1. And then let's take a look at the graph and see if that's what we got. It appears we have reflected across the x-axis. Now let's figure out how to reflect across the y-axis. Here we're going to take our original function, but now we want to make that replacement for the x values. So we'll take advantage of the function notation again. I want to use the function in y1, and then, but I want y1 of negative, not minus, x. And if we look at the graph, we can see that the y value I got from 2 is now the y value I get at negative 2. And the y value I get at 3 is now the y value I get at negative 3. All right, so let's recap. How do we make these reflections? If I multiply the whole equation by negative 1, I end up with a vertical reflection of the function across the x-axis. And if I multiply each x by negative 1 in the equation, then I end up with a horizontal reflection of f across the y-axis.